Good morning. Today I am coming to you with an introduction to the new subject operating system for CS4 students of IPT and GPT Shoranur. So before coming in detail about today's class, let me have an introduction about the COVID-19 pandemic. So this is a safety alert for you. Coronavirus disease 2019, or we are saying all are familiar, COVID-19 prevention, what you need to know. So you all know and everybody is aware of this. Wash your hands frequently, always wear face mask, and if you have any symptoms or any uneasiness, be at home and don't go direct contact with anybody who is having any symptoms like cough, sneeze, etc. And always do not touch your face with your hands. Try to avoid touching your face with your hands. Wash your hands frequently with soap and water. Wear a face mask. If you have any symptom, even if only mild, stay at home. Use alcohol-based hand sanitizer when soap and water are not readily available. Cover your cough and sneezes. Okay, thank you. So we come to an introduction to the operating system. And the objective of this class is to describe the basic organization of computer system, to provide a grand tour of the major components of operating system, to give an overview of the many type of computing environments, to understand about computer memory and types of memory. So let me recall the von Neumann model of basic computer system. You're all familiar with this diagram and everybody knows about this diagram, and this is the block diagram of a modern digital computer, and this model was first put forward by John von Neumann. Everybody knows. So again, let me recall. We know the main components of a computer, main units of a computer system, and this is comprising of central processing unit CPU, and input unit, output unit, and memory unit or storage unit. And you know the heart of the computer and the base of the computer is the CPU, and it is having components like control unit, arithmetic unit, and there is an input unit through which programs and data fed to the computer, and it will be intermediately stored in the primary memory and secondary memory, and also the results are produced to the output as output to the users, or whoever who want the result, it will be coming through output unit. So everybody is familiar with this block diagram of computer, and it is also called basic organization of a computer system. Now let me ask a question: what is an operating system? So this also, everybody is familiar with this term operating system or OS, and immediately when you hear the name OS, immediately your mind is having a picture of a desktop or a laptop screen. So when you put on a computer and after some initialization process is finished, you will see a window. Okay, nothing else, it is a Windows operating system. So it is a Windows operating system, and you are using, or you are sitting a computer on a platform normally with Windows. So this Windows is an operating system. Everybody knows, you knows, and everybody, even a normal man, without having any computer knowledge. He knows what is Windows, what is computer, and even he may be knowing about the von Neumann architecture that I shown you in the previous slide. So let us see what is an operating system. A program that acts as an intermediary between a user of a computer and the computer hardware. So simply, you can say that an operating system is a program. So sure, it is a software. So you know, I know that you can recognize or you can distinguish the word hardware and software. So that is the first category we are always mentioning, hardware and software. And you know the hardware and you know the software. What is hardware? What is software? So hardware, all the physical components, where you can see and touch, this is a hardware. You know that the components of a computer is comprising of the term hardware. And software, you know, the instructions or whatever the information, instruction, programs or data, everything we can say as software. So software or a program is also under the category of software. A program is a set of instructions to the computer. So instructions are under the category of not the hardware only. It will come under the roof of software. So naturally, operating system is also a software. Everybody knows, and you also familiar. And I am emphasizing that operating system is under the category of software. So we'll try to give a simple definition or a basic definition of operating system. So the question is, what is an operating system? It is a program that acts as an intermediary between a user of a computer and a computer hardware. So it is a middleman between the user and the hardware. So that is why whenever you are opening a laptop and sitting in front of a laptop, you are using or you are working under the guidance or under the over the platform of a operating system or a Windows. For example, here Windows. Not only Windows we are using, there are a lot of operating system available in the market, and the most popular one is Windows. But it is not popular means it is not the most powerful. We cannot say like that. But economically cheaper and most popular operating system available nowadays is the Windows operating system. And let us see operating system goals. The goals of operating system are execute user programs and make solving user problems easier. See, execute user programs and make solving user problems easier. So it will make the user problem solving easier, or it will execute user programs and make solving user problems easier. So it is a supporter for the programmer or user. It is a helpful mechanism or helpful program or helpful software or helping software, or it will help the software to execute or solve the problem easier. And make the computer system convenient to use. Very important point. Make the computer system convenient to use. So it is our convenience we are using Windows. It is not compulsory that you have to use Windows for operating your computer, but you can use Windows or you can use an operating system to make the computer hardware convenient to us, convenient to the user. And also use the computer hardware in an efficient manner. Use the computer hardware in an efficient manner. So hardware will be used in an efficient manner with the help of an OS. OS means operating system. Now you see, a computer system can be divided into 4 components. What are those components? Can you guess? A computer system can be divided into 4 components. Somebody can help me. What are the 4 components? So let me see. Naturally, the first component is hardware. Next one coming operating system. Third one is system and application programs. Fourth one is user. So we can say a computer system, or we can call a computer system as a combination of hardware, operating system, system and application programs, and user. And what is the system and application program? Anybody can tell? So system programs, application programs, everybody knows. System programs means assemblers, compilers, interpreter, etc. Who or these are all the software which will translate the higher level instructions, means application programs, into machine language or system language or computer language, which is called machine language. And application programs are the programs that we write, the user writes. Say for example, railway system management, hospital management, these are all application programs. Or an instruction set of instructions to add 2 numbers, this is application program. So system programs example is, say, C compiler, C++ compiler, Fortran interpreter, Pascal interpreter, assembler. Assembler. Assembler, what is an assembler? Assembler means assembler will translate assembly language into machine language. Compiler will translate higher level language like say C programming, return the instruction written in C program into machine language. So C compiler, then it is called C compiler. If you are if it is translating C program to machine language, then it is called C compiler. And users, we are the users. I am the user, you are the users, and all are sitting and using the computer. Even without programmer or any user, any layman who is using the computer, we can call them as user. So again, a computer system can be divided into 4 components: hardware, operating system, system and application program, and user. Again, we'll try to define the basic computing resources: hardware, CPU, memory, I/O device. Operating system controls the hardware and coordinates its use among the various application programs for various users. Application program define the ways in which the system resources are used to solve the computing problem of the user. Example: word processor, compiler, web browser, database system, video game. Users: people, machine, and other computer also. This is very important. Users means not only people, machines, other computers who is using the, when one computer is connected to another and he is using this computer, then that is also under the user. So hardware means it is area, you know. Operating system, that also you know. We tried we had given a basic definition of operating system, application programs, users. You see, this figure illustrate the same thing, that is computer hardware, operating system, system and application programs. You see, compiler, assembler, I told you, text editor, database system, etc. User 1, user 2, user n. Then maybe user 2 is another computer. So this is the hardware and this is the operating system, the system and application program, and user 1, user 2, user 3. I think it is clear to you. Everything is very simple and very clear. Computer hardware, this is the layered approach. You see, layered approach, this is the layer. So when you look into this figure, you can understand that we are sitting a hardware, or we are approaching to a hardware. If you are sitting in front of a laptop, that means you are sitting in front of a hardware. You can see only hardware surrounded by an operating system and also surrounded by some system and application programs like compiler, assembler. So you are sitting actually in front of a virtual computer. What does an operating system do? Depends on the point of view. Users want convenience, ease of use, and good performance. Don't care about resource utilization. So, what about user didn't know what an operating system do inside. He only want convenience of use, or he only want to use his laptop or computer in a convenient way. But shared computers such as mainframe and mini computer must keep all users happy. We'll discuss about mainframe and mini computer in next sessions. Just understand the term mainframe and mini computer. So whenever a system is using multiple computer in a shared manner, then all users should be happy. So operating system should share the resources in such a way that all users are happy, or he should not think that I am sitting idle or waiting for something. Users of dedicated systems such as workstation have dedicated resources but frequently use shared resources from servers. Handheld computers are resources poor, optimized for usability and battery life. Some computers have little or no user interface, such as embedded computers in devices and automobiles. Now you see again operating system definition, different definitions, or we cannot say one definition, or we cannot fix an operating system in one word or one sentence or one definition. So it has multiple functions. It has multiple functions to do. OS is a resource allocator, manages all resources. It decides between conflicting requests for efficient and fair resource usage. OS is a control program. Previous slide also, we defined this one. OS as a control program. Controls execution of programs to prevent errors and improper use of the computer. OS is like a government. It simply provides an environment within which other program can so useful work. So the other program also do useful work. So it will give an environment. It will give an environment to work others efficiently with a computer. So what the government's job, or a government, a government, it provides support to all. In the same way, OS is like a government. Now we'll try to define again operating system. So when you go into deeper and deeper, you can say that there is no universally accepted definition for operating system. Then how we will define? Let me see the simple and powerful definition. That means operating system controls the hardware and coordinates its use among the various application programs for the various users. So operating system controls the hardware and coordinates its use among various application programs for the various users. It's a simple definition, and you can remember always this definition in future. The one program at all time on the computer, that is the operating system. The one program running at all times of the computer. It is called kernel. Usually operating kernel is operating system, or it is the module of operating system. You cannot say the full operating system is always available in your memory, but the kernel or the essence of that operating system, it is called kernel, and it is always available or residing into the memory or always residing in the main memory of computer up to the power is switched off. So whenever you switch on the power, the kernel will be residing or kernel will be copied there and it will be residing until you finish the execution of computer. Everything else is either a system program ships with the operating system. You see, it is as you can also say a system program ships with the operating system or an application program. So a system program or an application program, and whatever everything else is either. That means when you buy some software, if the software is not in the under the category of system program or an application program, then it is always will be operating system. So that is a concept only. You see, a computer system organization. You can see the figure. A computer system organization like this. You see one or more CPUs. Here only one CPU is drawn here. Device controllers connect through common bus providing access to shared memory. You see, the memory is shared and common bus where the data are passing, instructions are passing to the CPU and other devices. So here some common resources are shared by these peripherals. Peripherals means this control is there, USB control is there, graphic adapter is there. You see, so concurrent execution of CPU and device competing for memory cycle. You see, these devices are competing for some resources of the CPU and memory. So when they are competing for something, the operating system is a fair software or it is a supporting software to these controllers for a fair distribution of CPU time and memory time. So it will not make conflict, or it will not make starvation, or it will not make an ideal software will provide all the resources in a proper way to the CPU and memory in order to save the timing, or it will synchronize the device controllers and memory and CPU. So this is a idea. This is an idea how the OS works. Computer system, I/O device and CPU can execute concurrently. Each device controller is in charge of a particular device type. Each device controller has a local buffer. CPU moves from, this is the elaboration of that figure. CPU moves data from and to main memory to and from local buffers. I/O is from the device to local buffer of controller. Device controller informs CPU that it has finished its operation by causing an interrupt. Now, some storage notations and definitions are explained here. These are all familiar to you. I am having an idea that, or I am assuming that you all knows about the bit, byte, kilobyte, megabyte, terabyte and petabyte. So when you call a kilo, then you have to be in mind that 1000 kilo. So in this memory terms, we are telling that 1024 is the kilo. So 1 kilo or 1 KB, 1 kilobyte of memory means 1024 bytes, and 1 megabyte of memory is 1024 raised to 2 bytes. So then again it is coming, giga is 1024 to the power of 3, terabyte 1024 to the power of 4, petabyte 1024 to the power of 5, like that. So that is the memory capacity. Now again, computer startup. How a computer is started up. So here you can understand that a computer always start up with a bootstrap program. Whenever the power is on, you will get a program which is, or which is this is a program loaded already stored in main memory called ROM, read-only memory, a part of main memory. This is read-only memory, or EEPROM, erasable programmable read-only memory, that is EEPROM, generally known as firmware. The program stored in ROM or EEPROM is called firmware. Firmware is not hardware and software. It is mid between hardware and software. So it is called firmware because this is a permanent memory. ROM is a permanent memory, and it is having certain small level of program called firmware, and loading up of this firmware is called bootstrap program, bootstrapping or bootstrap. So loading up of ROM is called bootstrapping or bootstrap program. So whenever the power is given to the computer, the bootstrap program is loaded. It initializes all aspects of computer system and loads operating system kernel and start execution. So loading of operating system is called booting. Loading up of the operating system is called booting. And when this operating system always residing in your hard disk or secondary storage device, and the ROM boot program or firmware will copy the essence of or the module of operating system, which is called kernel. It will be copied into the RAM. So before copying, the ROM will initialize the RAM area for storing purpose, and then it will load the kernel into the main memory. Then kernel will reside in main memory until you put off the power, and now the kernel will or operating system will take care of the system, and now you are prompted with the corresponding operating system prompt, say for example Windows, and now the system is ready for execution, or system is ready for user programs or user usage. So now you can also see main memory. Everybody is familiar about main memory. Main memory is a combination of RAM and ROM. And random ROM we already discussed in last slide, or booting process, read-only memory, you know. Now you are familiar with read-only memory. Now random access memory is called volatile memory, means when you put the power of the content in RAM, random access memory will be erased. And you know, the secondary storage devices, like example as an example, hard disk, floppy disk, USB operated devices like flash memory, etc. These are all secondary memory, and these are all non-volatile in nature. That means when you put the power off, the contents will not be lost. Whereas the RAM, the content of the random access memory, the content of the memory will be lost when you put the power off. And some main memory, only large storage media that the CPU can access directly. You see, random access memory, it is volatile. Secondary storage, extension of main memory that provides large non-volatile storage capacity. Then hard disk, rigid metal or glass platters covered with magnetic recording material. Disk surface is logically divided into tracks, which are subdivided into sectors. The disk controller determines the logical interaction between the device and the computer. Solid state disks, faster than hard disks, non-volatile, various technologies becoming more popular. Storage system organization in hierarchy. You can organize a storage system according to speed, cost, and volatility. You know the speed, cost, memory cost, and volatility. And one more term you have to always remember is caching or caching, and caching, caching. Copying information into a faster storage system. Main memory can be viewed as a cache of secondary storage. device drivers for each device controllers to manage I/O, provides uniform interface between controller and kernel. You see the storage hierarchy. You see the top speed and cost wise also. When you look into storage hierarchy, you can see that there are registers, cache, main memory, solid state disk, hard disk, optical disk, magnetic tapes. So when you come down, the capacity also increasing and the cost is reducing. So this is the way the computer memory is organized. Now let me conclude. So today's session we came with an introduction to the computer system, and we see the computer architecture, the organizing diagram, block diagram, von Neumann diagram you can say. Then we come to the four components of a computer, and then we try to define an operating system and the function of operating system and how a booting is processed and what is kernel. And now again we come to the elementary portion of memory, byte, bit, like that, and then we come to the various terms of memory, categories of memory, volatile and non-volatile, and some caching, and also the hierarchy of storage device. These are all the basic portion when you discuss about in detail about operating system. So next sessions will come to the deeper memory allocations, multi-frame, multi-processing system, mainframe systems, memory management, etc., etc. We'll discuss in later sessions. So any question you want to ask today, we can feedback and question answer. So any question you can ask. This is the conclusion. So memory and its management. So memory management we have to study in detail in next sessions, but today as an introduction you know about the memory hierarchy, memory types, memory management, etc. And also at least you can define with a simple word or in one or two sentences about an operating system. So I hope that you know about the terms that we discuss about, and you have to revise it, you have to be familiar with it, and next class we'll revise it again, the points we'll revise it again, and we'll go in detail about each term that we discuss in today's introduction. Okay, thank you very much.